Hi everyone, and welcome back to another episode of Dr. Kyle Explains, your YouTube channel where we go through GCSE science content quickly and easily. Today we're going to be going through Group 7, the halogens. So if you like the sound of that, grab some paper, grab a pen, and let's go ahead and jump in. Okay, so first of all, we're going to go through some key content. Group 7 is also known as the halogens. They all have similar properties due to having 7 electrons on the outer shell. The halogens are nonmetals and consist of molecules made of pairs of atoms. And so what that means is you have things like Cl2 or Br2. And so whenever you want to write just the element for any of the halogens, always put it in a pair. It's a diatomic molecule, 2 molecules. So going down the group, their density, boiling points, and molecular mass all increase. And the reactivity decreases going down the group. Now remember, that is different from the alkali metals. The alkali metals get more reactive going down the group and less reactive going up the group. So this is the opposite way round from the alkali metals. Now, finally, don't forget to smash the like button and subscribe to the channel. Okay, so just want to go through some displacement reactions. A displacement reaction is where a more reactive element replaces the less reactive element. And so in the case of the halogens, a more reactive halogen, remember the ones further up the group, will displace a less reactive halogen from an aqueous solution of its salt. So aqueous, just as a reminder, means dissolved in water. And so if you put a halogen, like chlorine for example, dissolve it in water, it would be chlorine, and then you would put this little symbol next to it, aqueous, to show that it's been dissolved in water. So let's have a look at some examples here. So what I'd like you to do is just briefly copy out this table where we've got chlorine aqueous, bromine aqueous, and iodine aqueous. And then we have some salts of potassium chloride, potassium bromide, and potassium iodide, all aqueous salts. And so what I want you to do is very quickly just write in whether you think there is a reaction or not a reaction. So for example, if you thought there was a reaction in this one, just write reaction. And if you thought there was a no reaction in here, no reaction. So can this halogen displace the halogen from this salt? Pause the video and have a go. Okay, so hopefully straight away you can see that chlorine versus chlorine is not going to do anything. So we'll just put a little cross in that one. Bromine and potassium bromide, it's not going to do anything. So again, just going to do a little cross. And iodine again, it's not going to do anything. So let's look further now. Now, bromine is lower down, and so it cannot displace the chlorine. And so this one would have no reaction again. Iodine is further down the group, and again, no reaction, cannot displace the chlorine. And then finally, iodine is lower than bromine, and so again, no reaction. Now, looking over on this side, chlorine is higher than bromine, and so this would have a reaction. And so what would happen? The chlorine would kick out the bromine, and so bromine would be released into the solution. And so not only that, the solution would turn kind of like a yellow colour, because as you go down the halogens, they get darker in colour. And so the chlorine, which is kind of like a pale greeny kind of colour as a gas, and then in solution it's kind of very pale yellow, it would kick out bromine, which is a far darker yellow. Now again, chlorine and iodine, chlorine is more reactive than iodine, and so this one would have a reaction. And again, iodine would be released into the solution, and so this would kind of be like a dark orange colour, because they get darker as you go down the group. Now finally, bromine, more reactive than iodine. Again, this would have a reaction, and again, the solution kind of would be a dark orange. Now, you don't need to know specific colours, you just essentially need to recognise that as you go down this group of the halogens, they get darker if a displacement reaction occurs. Okay, so equations for the displacement reaction. Potassium chloride plus iodine. Iodine is further down the group, and so they get less reactive as you go down, more reactive as you go up. And so hopefully we recognise no reaction can take place. Iodine cannot displace the chlorine. Looking at the other way now, potassium iodide in the salt, chlorine is more reactive, it's quite high up, and so chlorine replaces the iodine, kicks it out, displaces it, and we make potassium chloride plus iodide. And again, because we're getting rid of that iodine, darker colour in solution. Okay, and so the reason for this is the reaction completes because chlorine is more reactive than iodine, so a displacement reaction can occur. Okay, so let's look at the trend of reactivity. Remember, trend means pattern, and so the reactivity of group 7 gets less reactive going down the group. So as you go down this group, it gets less reactive and more reactive on the way up. So let's use fluorine and chlorine as an example as to why. So chlorine has more energy levels, 1, 2, and 3, compared to fluorine's 1, 2. Chlorine's got more energy levels. So there is a greater distance between the outer shell and the positive nucleus compared to fluorine. So remember, we're going to use our letters D, F, and E. And remember, from our alkali metal video, and I suggest you watch that if you haven't already, this stands for distance, force, and electron. And so we've now written about our distance, tick, greater distance for chlorine. So what this means is from this outer shell here to the middle of that positive nucleus, there is a greater distance compared to fluorine. So what does that mean? So the force of attraction in chlorine becomes weaker. Therefore, it is harder for chlorine to gain an electron. And so hopefully we can recognize that because fluorine wants to gain that 1 electron to get a full outer shell, and fluorine wants to gain that 1 electron to get an outer shell, fluorine is more reactive because the force is stronger, chlorine is less reactive because the force is weaker. There's a bigger distance there, making the force weaker. Hence why chlorine is less reactive. Okay, so I want you to have a go at this question yourselves now. Write this down on a piece of paper. Why do the halogens get more reactive as you go up the group? So remember, use DFE as a way to structure your answer. First of all, talk about your energy levels, then move on to DFE. Try and get 3 marks, see how you get on. Pause the video now. Okay, so let's go through the answer. So why do the halogens get more reactive as you go up the group? So as you move up the group, the halogens have less energy levels. Essentially, that means they're smaller. So the distance between positive nucleus and outer shell becomes less, or is reduced. Tick. So the force of attraction becomes, let's have a quick think now. So if the force of attraction, what's happening there? If the distance is becoming less, the force of attraction becomes stronger. Therefore, it becomes easier to gain an electron. Perfect. Making them more reactive as you go up. And so here, quick check them. We've spoken about our distance, we've spoken about our force, and we've spoken about that electron that we want to gain. Really well done if you got that right. Okay, so today then we've described the properties and trends of the halogens and complete halogen displacement reactions. Thank you very much for watching. Please do go through my other videos for more help on your GCSE science. Please like the video, subscribe to the channel, and remember, if you need any more help with your GCSE science questions, Dr. Kyle explains. Thanks very much. Bye-bye.